Okay, who's going to be first on show and tell? Somebody? Okay, come on.
This is the robot from Wayne's class, with the basic functionality. So I'm just trying to get it ready for the tabletop challenge next month. I don't know if it's going to work right now because it did do. I mean, it needs some tweaking, and we just try it. So it does escape the table falling from there, and once it gets the target, it looks for once it gets the ball or the object, it looks for the target. So right now I just take this as a target, and then it keeps going there to drop it.
Oh, that's great.
It just, this needs more tweaking.
Great.
Robot with my mom.
Yeah, she helped testing it with me, and the target we have at home, and I didn't bring that because it wasn't working completely. So she's helping me out in testing.
Great. Okay. And if you notice any similarity between these robots, it's because they came all from the same starter class that we started at the beginning of the year. I'll talk about this one a little later. Okay, thank you very much. Who's next? I saw some hands back there. You want to do Hercules, David? Okay, could we bring it up? Because otherwise everybody has to twist their heads off. Oh my. Okay.
Okay, so what we have here is Hercules version 3. This is the third iteration of Hercules. This is roughly what the thing looks like, or this is what we anticipate the thing will look like when done. We have two brushless DC motor controllers, battery, electronics. This is our working version. As you can see, we have LiDAR, camera, and computer. The computer is currently set up to run ROS, and the brushless motors are controlled with a ROS node. ROS obviously is a lot of fun to play with. It allows you to sort of make up some behaviors, and I'm going to try one behavior right now, which is what we call Party Bot. And what this behavior does is that it drives around, it searches for somebody, you can see it's found me right away, then drives towards me. When it gets close enough, it stops, like there, then we'll make an offer, and in this case it can say, would you like something to drink? It sort of hangs around for a few seconds and then it drives away. So that's the party bot behavior. Let me just switch this on. What's that? So that is Hercules version 3. And a little bit more development on this, and then we'll try to develop the next iteration. Thank you very much. So this is all part of the $500 robot challenge. We're trying to build a highly usable robot with a cost of less than $500. A couple of you have been asking me about the hub motors that we use. For those of you who are interested in hub motors or the chassis or getting one of these things, then come see me afterwards. We may be able to do something at cost for people here in the club. We come together and we hack on this robot together on Saturdays in the Hacker Dojo at 1:30. So if you're interested in joining us to try to jointly develop a low-cost robot platform, come and hack with us. Saturday at 1:30. Okay? Thank you.
So back when we were a much smaller club, we were always saying, wouldn't it be nice if we had an HBRC clubhouse? And I'd like to point out that Hacker Dojo is basically turning into that. If you show up on Saturday, robots happen. So if you've got a free Saturday, come on over. The kickoff meeting is at 1:30 every Saturday. Okay.
Work on electronics.
Yeah. Okay, who's next? Ready?
Yeah, this is actually a sumo bot, and he and his brother are just working together for a week and a half. You want to explain something? Okay. So basically, it has it's based on the Arduino board and has 4 sensors below. It keeps in the ring, and it has sensors here which can track the other bot and go and fire it out, and when it comes off the ring, which it can sense to remain inside through 2 sensors here, it will you basically lose. So they are in the process. He just fixed it, and his brother, they are attempting to program it. You want to see something? Okay. You want to try it out? Good. The black man. Oh no. Okay. Okay, right now it's just going around in a circle because we have to adjust this to motor. Okay. Thank you.
Okay, thank you very much. Yep, some progress, quite well. Okay. So we're trying to get the signal up on the screen. Yeah. Is that it? Okay. We need to wire you up.
Do you hear me now?
Yep.
Okay, so I'm working with the guys from the team Walk Like a Man, and we are preparing for the Dark Robotics Challenge. And this is our robot, and the white one. The big one is the utility vehicle that will need to be driven by the robot at the challenge. So I was playing with the gazebo simulator, and this is the simulator, and I made a small sequence. Where's my mouse? Where the robot at least stands up on the buggy. Hopefully you will see a picture like that in a servo magazine soon. Yeah, that's about it. But even with the short simulation, it turned out to be quite useful because we were able to discover that it will not be that easy to press the pedals with legs like this, and it will not be that easy with this leg configuration to actually sit on here and press the pedals. So we will need to think about it. Yeah, that's it. Thank you.
Very good. So, Katia, show us your robot.
Hi, this is my robot. My name is Auntie Bravo, and this is Johnny 5. And where I got to make this, why I made this, is, and where I got the robot from, is, so I'm just building, or, oh yeah, so in this computer, there's instructions how to make this, and Johnny 5 is from the movie Short Circuit. Has anybody seen the movie Short Circuit? So yeah, and I got this from there, and there's 6 motors, 2 for the tracks, 1 for the back to go up and down, another to move the head, another one to shoot the laser, and another one to move both arms. Any questions? Yes?
Is there a real laser that shoots out, or is it?
No, it's just a light.
Have you ever seen the movie that has Johnny? That's
Yeah.
the other name, Charlotte. What's
Yeah.
the name of the other robot?
What other?
Short Circuit.
Uh-huh. What
It's Johnny
other?
4, right?
Uh-huh.
Yeah, okay. So, okay, very good. Thank you. Okay, who else has robots? Are you ready? Okay. Camp, did you raise your hand? Okay. Start moving forward. You're ready.
Hello. Okay. So I didn't really bring a robot, like it's over there, but not for show and tell. So basically I got this beagle bone and I'm trying to work on like a client user system, sort of, and like a server client system. And so I have Sarge, my robot, who was at Maker Faire, and it has an Arduino and it has like there it is right there. So that's Sarge, and he has an Arduino and he's loaded with a bunch of hardware.
When you bring your robot, show
Oh,
it.
yeah, so this is sorry. So what I want to do is use the BeagleBone and its GPIO to like use it to control the like Sarge from a remotely. So like a user or somebody can just give a command and then it can move around and do different things. So this will be like mainly like the brains, and then like it'll just delegate its operations and other things to the hardware and systems of Sarge the robot. So that's basically my idea. So it's a work in progress.
Does it drive around?
Very good.
Can you drive him around?
Not yet with the BeagleBone, but like I can
Can you move?
Yeah.
Just move it. We want to see demos, Sid.
Might be a little dangerous with the table, but I'll try.
Put him on the floor. Put him
Yeah,
on the
it's
floor.
better
It'll
if
feel
you
better. Don't drop the robot. What kind of batteries you got in there?
It's a big 12-volt DC battery.
Seal lead acid?
Oh yeah.
Don't like it. Doing surveying the area.
For those who didn't notice, like there's an infrared sensor, and every time I put my leg in front of it, it just turns the opposite direction.
Put him in the center.
Yeah. Yeah, so that's Sarge.
Okay. Excellent.
Oh yeah.
Can we do the table just push it back, because I was going to use that, the podium as my barrier. And to get this area clear from the bottom down.
We need wiring one.
Area. We can keep this area. Okay, like that. Okay, I got my pocket. Okay. I'm going to attempt the demo gods here. I finally got the Glyptodon bot running with actually a real ROS program, because as I found out, ROS is an operating system, which means that you still have to write your own software. So this is for the Floorbot challenge. This is the phase where the robot traverses some distance, encounters a wall or an obstacle, turns back, and returns to
roughly its starting point. Hold on. Serial exception. This probably happened when I turned it around. Hold on.
Yeah, okay. Like I said, I was going to have the demo gods.
That's what you get, man. Live by the demo guy, by the demo hub.
Phase 1, blame the batteries. Phase 2, blame the Wi-Fi.
Phase 3, blame the driver.
Yeah, this is phase 3. Blame the driver.
You'd like to create driver crash or something?
Yeah.
Just restart.
You want me to?
Okay.
Hold on.
But we're going to give you some time to develop, and we're going to
Okay.
the next group. Well, John's ready to go, aren't you?
Yeah, go ahead.
Come on, John.
Are you ready?
Yeah, our robot is named Zybot. It's off to the left. It's gray and silver. We have Marcus helping us. He's doing telepresence. We have a camera on top. Well, hopefully he can see and maneuver his way over here. So it might take him a little bit. He's never driven a robot, so this is how we roll. That's like how we like to do things. And as soon as he gets over here and they're close enough, I'm going to move that camera to where the hand is, and he'll attempt to lift this the bottle. He may never make it. Both wheels are moving. For a second, I didn't think both wheels were working, but it is. There he comes. All right, that's perfect. Good enough. Turn to the left, which would be your right. There you go. Perfect. All right, I'm going to change the camera for you so you can look over the hand. You need to open up the hand. You're making your arm go up. If I remember correctly, that hand should open. It should be the left one, the left controller, for the hand to open and close. That's probably your right. And how you doing over there, Marcus? There you go. Go the other way. You had it open. There you go. So there you go. It's open. So now, if you would like to try to go for the bottle over here, can you see over the hand well enough? Our camera system is 900 megahertz, so at least it works there at Noble. It's not being interfered with anything. In the future, we're going to have more than one camera. The system we're going to get is going to have 4 cameras on it, and they should be able to flip-flop, and hopefully it'll be under 900 megahertz, so that way there's no interference, because that's the biggest problem here.
about how many frames per second does the see on the cameras?
That's a good question. I don't even know. This was we just got a camera, and it's the last one that they make. And so we saw another one, same company, similar. You know, so runs, I guess, a closed circuit. If you drop your arm just a little bit. Well, that was a good try. And he's under control. Out of control. All right. Thank you very much. We tried that. Okay, ready to try again.
Okay, we're gonna let Bill give it another try. We're gonna.
Okay, so this is robot again. Robot is. Let me know when you're out of the way.
We're out of the way now.
Okay, I'm gonna wait for him to get out of the way. I'm gonna wait for the robot to get out of the way. Okay, there we go.
I'm trying to take the time. Sorry about that.
No, that's okay. I wanted.
I don't want to interfere with your program.
Okay, so it's going to take it a few minutes because it's moving along pretty slowly, but this is the Glyptodon bot you've seen me working on for a while. It's using the laser, so I've had the laser data going for a while. You've seen it up on the screen, and now it's actually processing that. I wrote some code that instead of taking in the whole scan, I can actually define like an aperture of data to consider. So I pull in the scan and then only pass in a certain chunk. So it's like a 20-degree window, and when that window is obscured, it will turn around. It'll turn around. Turn, robot. You're supposed to be looking there. There we go. There we go. And I think the cable messed up the odometry a little bit. I'm just gonna readjust manually there. So what it does is it computes it looks at the aperture the aperture of the range of laser data that it's supposed to be looking at, and when it gets to be beyond a certain percent occluded, when it gets to be like 70 or 80% occluded, out of that slice or aperture, it considers the area blocked, and then it will turn around. So hopefully this will just keep going. This will turn around here, and it'll just keep going back and forth, and back and forth, and back and forth, and that's basically it. I still need to tune the actual. I think I actually need to like read the gyro a bit more close, pay more attention to that. But that's basically phase one. It's overturning a little bit, probably about like 10 degrees. It's actually probably like about a 190-degree turn. But that's basically it. So it's actually really using ROS and it's running real code. That's the major thing. And it's using a needle LiDAR.
Yeah.
And this is all pretty much off of my own hacked together ROS distro. It's based off of Groovy, a lot of source compiled, some packages built, and some other bits kind of hacked together by myself.
And for people who do not know, ROS stands for Robot Operating System. It was developed by Willow Garage, which alas is no more. Okay, next up is camp. We got to wire you up camp for the tent.
Look at all the technical stuff to make television. PR2 Let's do the technical So Ross gets sort of like
Test 1, 2. Okay, hi. The 18 Oracle. All right. So this is another ROS-based robot. This is Loco Mode, the smart table. I painted him orange. Hello.
Is that the standard Neo color?
This is it's a Nito XP11, and I've basically Velcroed a computer to it. The computer's running ROS, Robot Operating System for Willow Garage, and I'm using the Nito node. And let's see here. Right now I'm just remote controlling it, but I'm creating a map. And it looks pretty dodgy right now. Can you show that?
This is the video.
Yeah, oh, sorry. Anyways, yeah, it's a pretty wide open area. But which brings me to what I wanted to mention is next month is our 11th annual Phase 3 Challenge. This is what we're all about, folks. We build robots here. We don't just come talk about them. And so we've got two big events that we like to promote, and that's the TableBot Challenge and the new FloorBot Challenge. And then we always have Run What You Brung. Hey, Dave. We have Run What You Brung, which basically means you got a homebrewed robot, bring it, we want to see it. And so I'll start nagging you next week, motivating you, that is, next week with those motivational emails. Ooh, let me show one more thing, if I may. I'm building a new skeleton. And John and John gave me this little baby. And some of you maybe remember Homer, the homebrewed humanoid. It's been described as both whimsical and disturbing. Anyway, so we're basically, he's growing up, he's salvaging, thank you. He's salvaging Homer's servos, so I guess this is going to be Homer 2. But that's funny. Like, but see, it's got bones and stuff, and I'll use the Arduino. And next month, that's my challenge, is to have him dancing and be part of the Black Mass Dancers. We'll do a little performance for you. But regardless, next month is our challenge month, so everybody here is building a robot, right? Otherwise, why are you here? So bring your robot next month, and we do fast round robins. It's all about the demo, and it's always a lot of fun. Thank you very much.
So I know you mentioned you're using Arduino, and the Arduino, of course, has a lot of cool stuff to it, but yeah, it just seems to me like you ought to be using a Beagle bone just for the humor of it.
Well, you know, you use what you have. For that matter, the comedy musings of Dave Curtis, ladies and gentlemen.
I have one other quick question.
I was getting off defensive there.
The XV11, is it still under warranty?
My XV11? You got an XV11 with a problem. I know a guy that knows a guy, so let me know about it, and we'll fix whatever ails you for the most part. Thank you very much.
Okay. Now we're going to hand it over to you.
Okay, so everybody knows that your robot always works at home and never works when you bring it in. So we filmed it at home.
and we didn't take it. So this guy is, he's powered on his own, and that means he's standing and balancing on all the joints, and he's just sort of waving his hands, which sort of changes the center of mass, and he's able to stand up. And we needed to have this film to send to DARPA so that they knew we were for real. And we have a deadline of the end of October to have him walking through a door in a certain, over a 6-inch block, and he also has to go through a doorway. So we're going to really put a lot of effort into this for the next month. One of the reasons he can't walk now is because the servos that are on there just can't handle the job. So we have these newer style, super beefy servos that are possible to get, and we're managing to get some of them. That's going to give us the torque we need to solve our problem.
What do you make those hands with?
Yeah, those hands are from Home Depot. They're fully articulated. Yeah, sure they are. Yeah, well, we didn't want just knobs at the end of his arms. So this, we're not going to bore you with how long this goes. This goes for 43 hours before he falls over. No, he doesn't. He goes for 6 minutes, so we're not going to bore you. And then all of a sudden he just sort of gets tired and he falls over and collapses. So we're going to try to hook him up later after the meeting and turn him on. So he's not bolted to anything. No, he's just standing on that because I didn't want to scratch my hardwood floor with the load cells on the bottom. So that's it.
Very good. Okay. Are there any last show and tell robots? Because I'm going last. Okay. For those of you who don't know, last spring we taught a class for the people who needed an introduction to robotics. Okay, you saw one earlier. Okay, we're getting ready to do an add-on to this. Okay, and the add-on is to add a Raspberry Pi processor and the ability to talk to the robot via Wi-Fi. Okay. This took quite a bit longer for us to bring up because we were having troubles getting reliable Wi-Fi. I'm not sure it would be reliable here because Google just coats the airwaves with Wi-Fi. But we're ready to go. If you're interested, come up afterwards and ask me questions. We're ready to start taking orders for add-on kits. If you weren't in the original class, you want to pick up a Raspberry Pi and Wi-Fi, we're okay with that. But I just want you to know that it's primarily for people who are in the class. Okay, so that's really all I wanted to say. See me afterwards. Okay. So thank you for all these great robots. And what we're going to do now is we're going to do a 5-minute bio break. Okay. And this will let Tony get everything set up, and then we're going to roll and let Tony give his presentation. So 5 minutes. Thank you.